get set up. Yeah, so I wanted to talk basically about the software, the process of how I kind of build software, how it seems like it's changing, and also just everything that kind of goes into making those decisions. Do you guys see the slides on the screen? Cool. Let me do 1 second. Appreciate the Optimus mission getting us new desktop backgrounds. There it is. Okay, great. The slide title is a mouthful, and but it's it touches everything that I really care about, which is making good products and then the engineering behind that, because I think that they're really tightly coupled. And so a bit about me before we begin. I'm Rhys. I really love building products, and some of what I've worked on includes Answer Overflow, an app that I made back in college like 3 or 4 years ago that now has 1.5 million monthly active users and does like web pages from Discord threads. Last year I worked with an incredible team at Vercel to revamp the domains product area. And we helped take it from being kind of this like neglected part of the product to just an extremely strong area with the fastest domain search on the web. And then lastly, I'm now building a company called Executor, which is an integration tool for AI agents, which lets your whole team securely call your tools. Okay, so what we're talking about is basically product thinking, what my process looks like, how I go from a problem to a solution, then how I write code to implement that solution, what it looks like in practice, how you get people to care. The talk title has AI in it, but one of the kind of funny things with AI is it's just accelerating and reinforcing all of the things that mattered before AI, and that's tests, being able to iterate on your software, etc. So it just makes that more important than ever. And the other thing that I really like is, to me, React is kind of a means to an end to building products. I really love the technology behind it and what you can do with it. But the other thing is, it's really like one of the kind of amazing things is the blurring of lines between front-end and back-end development. And what's so interesting to me about product engineering is it's not scaling a database to kind of 1 million requests per second. It's about how you scale a product and a code base, and you solve the social and technical problems that come with that. And then the kind of last thing is what I mentioned earlier of, I think that if you kind of have good code and good engineering, you can eliminate whole classes of bugs from your applications that make for really good software. All right, so jumping in, the first thing up is product thinking, and this is basically going from a customer pain point to a solution. I really try and think of like features in my applications as primitives, and rather than putting 1 million features into the application, finding the one primitive that solves end problems for the customers. And so whenever I get feedback from the customer, rather than kind of immediately throwing it into Claude Code or ChatGPT, I try and think and process and understand what the underlying ask is. I want to walk through kind of a real example of that to explain what I mean. So for Executor, it's a product for teams that they can bring their own sources to. You want to configure it one time for your whole team, but each member might need to be able to put their own authentication on it. So you can imagine setting up the Vercel API for your workspace, but each member needs to be able to access their personal Vercel account. So if you put this into a coding agent, they'll be like, yeah, go add an organization ID and a user ID and call it a day. But if you merge that PR, you've now kind of limited your product and what you're able to ship down the line, because you've implemented these constraints on your product rather than figuring out what the underlying problem is. And so for kind of understanding that underlying ask, I really try and take the concept and the solutions that I explore to the extreme cases. And even if they're never going to be implemented in that scenario, it's really helpful for understanding where they're going to end up. So from the perspective of like, I need users and organizations, well, what if you need multiple workspaces in an organization? What if you need development, staging, production environments? What if you need like personal overrides of configuration? And for Executor, the concept that I landed on was scopes. The scope doesn't care if it's a user, a team, or organization. It's just a way that data is stored. And then the other thing is that you can merge these scopes. And so you have like your personal scope, and you have configuration. And what's really cool then is all of the primitives that you want to have, you can then just build off of this singular concept. I I did think to myself, though, am I overcomplicating this? Because the customer ask was, we want users to be able to override things. And it's gone from that simple ask to probably a week-long project to figure it all out. And then that popped up in my Slack the next day that I was thinking about it. And it is, that is the actual diagram that they sent me. That they were like, we want to add a source and then branch out on like these kind of different configuration types. And it was like very validating to go, oh, okay, this is exactly what I have planned out for the product. And I got to tell the customer that, and I wasn't kind of lying and fixing it in the process. What I think is really interesting is just because you can with the primitives doesn't mean you should. So I'm not going to then go like expose this raw primitive to the customer. Maybe that's there for advanced cases or for people using an SDK. But it's kind of a really interesting product engineering challenge to be like, okay, you've invented this primitive. Now how do you expose it to a customer in a way that they can use it however they need? And then the other thing is like, this is one thing that I'm pretty sure I'm stealing it from Amazon, but it's a very real concept of like these one-way door decisions where once you've baked something into your core data types, yes, you can throw an AI agent at it, and they're getting very good these days, but it still just creates friction and hassle and slows down your iteration loop. The other thing is for kind of how I think, it's the last part of kind of the product thinking part, is how I come up with product ideas or things to ship. I just try and notice a lot and then take notes of as many things as possible. So there's like really good threads on like how authentication should work, what issues people are running into, and there's just a ton of really good signal out there that you should listen to and see what you can do with. And so now for the TypeScript part of this talk. And this is basically just going to run through all of the patterns that I really think about in a day-to-day when I'm doing work. What's interesting is, as good as the coding agents are, they write kind of a lot of bugs and weird things in their software that you're able to write your code in a certain way to make it either more reviewable or prevent entire classes of bugs altogether. So the first one is, the first kind of high-level concept is making impossible states unrepresentable. And so TypeScript is an amazing language, and you can do all of these tricks in it to basically make invalid states fail at compile time. So you never put out an app with a bug in it because it's just not possible to represent when you build the app. And the other thing is it trims the number of paths you have to follow. And so looking at kind of two examples of that, one is branded types, and then the other is discriminated unions. And so for branded types, it's a great way for you to basically take a primitive type, say a number, a string, any of the primitive types, and brand it, hence the name, as a special variant of that. And so in this code snippet, you can see that I'm making a special branded type for phone number, and then I've declared a function that takes in a phone number, and I have this kind of user input that's just assigned to a string, and I'm trying to pass this string to a function that expects a phone number, and it's erroring. And you might ask yourself, Rhys, is that worth the complexity? It can just take in a string. I worked at Microsoft. We had 13 different ID formats for users, and every single one had to get routed to a different location. It was horrible. And it was all strings, all throughout the code base. I had to manually track it on pen and paper to figure out what was happening in that system. And so it's things like that that just pile up in your code base over time that if you kind of try and stick to some of these concepts, you're able to eliminate. And then looking at it in practice, so there's like two functions here. One is send SMS, and that takes in a string. It runs a regex against it, and then it throws an error. You might imagine that's a utility that's like validate your phone number. But now every single function that's dealing with phone numbers in your application can throw, versus the other function that just takes in a phone number, you know it's an invalid state. I will note on this, you can leverage classes in a similar way. So you could have like a phone number class. And actually what's nice about that is you can then put properties on it. So you could do like .area code, et cetera. But the thing that is really nice about branded types to me is they're like trivially serializable. So they flow really well through your application. And then the next up is discriminating against unions. They're great. You basically pick a key that's shared between all of them, and then you can do different data. If I ever see this in my code base, and you've added these different loading states with nullable data, so if you look at the first function, you check if it's loading state, and then the next one checks if it's an error state. But all of the kind of nullish values propagate all through your code. And it's just a lot more scenarios that you have to follow. Whereas the second function, I've tricked you into pattern matching. But again, it's just less code that you have to worry about. And it's super nice. This one's for kind of anyone making libraries. Even if you're making a library that doesn't turn to your company, it's great. It's standard schema. It lets you use any validation library. And so you can use Valibot, Zod, archetype, effect schema, any of these, all to the same function. It's super nice. Again, just kind of rapid firing through like the patterns that I like. Being able to pass objects instead of strings. So branded types technically fixes this one. In the first function, you see that it's possible for me to send, the first function is send email, and it takes in 2 strings, and it's possible for you to mix up the position. And you can basically send an object instead. There's a slight performance overhead on it, but you're writing JavaScript, so. I think these are pretty common now, type-safe API clients. So I assume most people are familiar with OpenAPI, and hopefully most people at this point are familiar with TRPC, ORPC, Elysia, TanStack Start, etc. But it's worth calling out because there's still places that don't have them. You're basically able to define functions in your server endpoints and then get them typed on the client, and you don't have to do any generation. The other thing is you're able to generate OpenAPI specs from them really well. Most of them have great support for it. And then kind of getting more into like conceptually how I think about TypeScript. One of the things that I really try and do is basically just let the types flow through the application. So in this code snippet, we've got const users, and it's assigned to a database column. I have that branded as an email type. And then I've got a server endpoint, so API endpoint, but it's written in the TRPC style way that returns the row. And then on the client, I'm calling that as useQuery. And you can see that it's kept the branded type all the way through. And so when you think about the amount of complexity that goes in, like, that just blows up through your application when you don't have these concepts. There was a Greg Brogman tweet from a while ago that was like, how did we write all that code? And this is kind of how we did it. Like, you find these patterns that you share throughout it. And these all work with coding agents. They fight it a little bit. And it's going to be interesting to see how it evolves. But it's really nice. I also want you to get more funky with TypeScript. Go look at any of the TanStack libraries for inspiration. This is one that I wrote for Postdog. And basically, when I tried to call it originally, I didn't have events passed. And then I uncommented events. And events I just automatically generated from my data in Postdog. Postdog's an analytics library that captures events. And so all of the types that you see coming in autocomplete here, like page view, features enabled, etc., I didn't have to manually type anything. It just inferred it all from my account. And you can do this for anything. I think autumn payments is another great example of one that generates it from your account. And again, it's like eliminating whole classes of bugs from your application because you can check all of this at compile time. Keeping your tests as real as possible. Basically, there's like logo stack. There's also like mini-flat. You can basically just spin up real Postgres instances, hit them in your tests rather than mocking stuff. Please don't put a million jest mocks in your code base. It makes it a pain to look through. Open telemetry, hopefully most people are familiar with, but you can take any request ID, see the span, see the breakdown. It's a pain to set up, but you can also put your agent on it these days. And then you can talk to your agent and say, why is my function slow? And then you can say, OK, make my function faster. And that's software engineering. That's where we've ended up. And it's time to share that I've tricked you all, and this is a talk on Effect, yes. For those of you that are not familiar, Effect is a library for JavaScript that basically ships with all this built in. It's got a type-safe API client, schemas, typed errors, branded types, open telemetry. Basically everything that like blows up the complexity of your code base, it has patterns to handle and works really well. There's probably 3 reactions in the audience. There's people that are intrigued and are going to go look at it. And then those people are going to split off into 2 camps, the ones that love it and the ones that go, what the hell is this syntax? Good luck. But regardless of how you feel about the library, the general concepts and patterns from it are really great to kind of learn from and bring into your code base. The next part is like when to do an abstraction. So this is the Answer Overflow project I mentioned at the beginning. And I'm making a GitHub issue out of a Discord message here. The UI that you see rendering in Discord here is a React app. This is a React app running in Discord. It's forked from a really great library called React Code. But the kind of concept I wanted to touch on here is if you see what's happening in Discord, for those of you that have tried to make Discord bots here, this is like an insane thing to do because you don't have like any of this, like trying to do loading states, you have to manually manage a bunch of states, all the problems that React is good at. And instead, the code kind of just looks like React, and it's incredibly reviewable because rather than trying to get like Discord.js and all these libraries to fit into the mold that I needed, I instead created like a shared abstraction that they can then use. And again, like we have agents writing code, but you still have to kind of look at the code. And that gets easier if it's patterns and concepts you're familiar with, and you're able to containerize it into different areas. Another thing is you can read, and I guess now ask about a ton of code. To just like follow people that ship things you respect, go read the source of open source projects. I would say when I'm developing with coding agents, it's like probably daily or like 5 times daily that I'm like bringing in open source projects, thank you MIT license, and saying, hey, I like the patterns in this project. Can we reference them and properly attribute it? But like the MIT license is incredible, and we've got a really great shared knowledge culture in software engineering, and like it really helps you make better software. I want to talk a little bit about what it's like to build these patterns in practice. So I have 2 open source projects I wanted to touch on. The first one's Answer Overflow. What's fun on Answer Overflow is it's this like amalgamation of things that technologies that I basically started it in college as a Python and Flask create React app. And every time that I've like improved as a developer and learned, I just get like have a real project to try out those patterns on and see how they feel. Where it's gone through like 5 rewrites. Where it's at now is it's on Effect, Convex, and Next.js. And I found that I really loved all those technologies for this specific application because, again, in terms of like trade-offs of complexity, it's not one that I want to spend a bunch of time maintaining. It's also one that kind of like needs to feel reactive. It's also open source over at Answer Overflow on GitHub. And then the other thing is if you want like a template to play around with, I extract a lot of the concepts from it into its own template. And then talking more about technology choices, the other project I mentioned at the beginning was Executor. So this is meant to be a tool layer for AI agents. And because of that, it basically has to run wherever people are running these agents. So that could be on a VM, that could be on a dynamic worker, that could be basically anywhere. And so it needed an incredibly boring tech stack that would be pluggable. And it's a completely different way of building, and it's just basically pick the right technology for the job. And then the last part is getting into my real expertise, which is getting views on Twitter. It's pretty fun. There's like lots of methods of distribution, and I basically just wanted to talk about how it works. And I think now that people are owning more parts of the product, it's kind of a good skill set to basically develop knowing how to put your work out there and get people to care about it. And so I wanted to break down 2 tweets. So I did this project maybe a month ago that basically just takes your GitHub chart and plots it as a graph rather than being the like square chart. And yeah, it just has like a nice visual. It gets people to share things about themselves. There's no auth, compelling screenshot. The data is interesting. It's really shareable. I will say, like, it's super fun to do these projects in terms of like getting yourself out there or like making something fun for people. I would not expect like high ROI on projects like this. You can like maybe try and throw your company logo on it, but people generally don't like that. I think it's more just to do interesting things. It's more fun to do interesting things just for the fun of it. If you do want a meta approach, you can highlight other people's work. I had a video on this and it disappeared. But I did this generative UI project back for the AI SDK with Postdoc. And so they like launched the RSC. They launched their kind of RSC project, and you were able to combine it to make these dynamic charts. And so I basically pulled an all-nighter after they launched it to hook it up to Vercel and Postdoc, put out this tweet that was like, hey, you can do generative UIs with real data. And put that out into the world, woke up, and it had like retweets from Vercel and Postdoc and kind of a lot of good engagement. And that was before I'd really like done many real projects. And it's just a very like nice way to get yourself out there and share the world. Another kind of awkward part is, does any of this still matter? Everything I shared on writing good code is a part of a skill set that I developed over years of looking at terrible company code bases that just killed their iteration velocity. And I care a lot about this skill set because at the end of the day, I want to build really good products for people. And I've seen what bad engineering does to products. It just kills them. However, the exponential project, that one, I shipped entirely from my phone, waiting 45 minutes for a sandwich. I don't know what's more ridiculous there, waiting 45 minutes for a sandwich or shipping it from my phone. But I didn't use any of these techniques. I didn't look at how it looked on desktop or what tech was used. I just made something interesting and posted it. And so that's kind of why this talk wasn't on TypeScript patterns alone. It was trying to be more focused on product engineering and how I think about that. But for what it's worth, the products from the labs don't feel good to use. I think it's really interesting how that's going to shake out in the next couple of years and see, do consumers care about software not being kind of buggy and broken, or are they fine with it? But overall, I mean, you can take all the concepts from this talk, turn it into a skill file, and tell your agent to follow it. So I'm excited to see what happens. Anyways, that's my talk. Thanks so much for the time.